Hello everyone, and welcome to our class video about proofs with CPCTC. Our learning goal for this video is that you'll be able to prove parts of triangles are congruent with CPCTC. Let's just review really quickly what CPCTC is. It means corresponding parts of congruent triangles are congruent. That is to say, if I have two congruent triangles, so like triangle ABC and triangle DEF, and I know that triangle ABC is congruent to triangle DEF, I can conclude a lot of things. I can conclude, for example, that AB corresponds to DE. They match. So that means, because the triangles are congruent, those two parts have to be congruent. Likewise, because C corresponds with F, then that means angle C must be congruent to angle F. Those are corresponding parts, and they are congruent, because the triangles are congruent. Got it? Okay, so let's look at how this looks in proof form. Okay? These proofs look like the ones that you just saw in the last video, okay? Where we first will prove that the triangles are congruent. But then, because of CPCTC, we can take it one step farther and prove that two pieces of the two triangles are congruent. Okay, so let's start off proving these two triangles are congruent. I'm given that RZ bisects angle TRS. I can mark that on the picture as angle 1 and angle 2 being congruent, and that'll come in as one of our statements later. I also know, because it's given, that angle 3 is congruent to angle 4, so I'll go ahead and mark that on the picture as well. Okay, which triangle congruence theorem would I use? Well, hopefully you're thinking it's angle side angle. Where's the side? It's the side in the middle, RZ. There. So now that I have a plan, let's write the proof. Our first statement is always our given. So we have RZ bisects angle TRS, and angle 3 is congruent to angle 4. That's given. Here, I already have one of my angles that I need for angle side angle. There's one of the congruent angles right there. Okay, so now I need a side. So the statement I need for the side is to use the reflexive side, RZ. So we'll say that RZ is congruent to itself, and that's because of the reflexive property, as we learned in the last video. Okay, so now I have a side. Okay, so now I need another pair of angles. The other pair of angles I need are angle 1 and angle 2. So I'll state that angle 1 is congruent to angle 2. And the reason is because all RZ bisects the angle, so this is definition of bisect. That's what bisect means. It cuts the angle in half. Okay, there, I've got my other angle. So since I've completed all three parts for my congruence theorem, I can write the next statement. And I can say that triangle RZT is congruent to triangle RZS. Remember here that the order of the letters matters, because we have the order I put the letters shows me which parts of the triangles correspond to each other. Note that you could have written this statement in another order if you so chose. What's my reason for this statement? Well, we were already using angle side angle, so it's the angle side angle congruence theorem. Okay? We still haven't gotten to the end goal yet. That's to prove this. But now that I know that the triangles are congruent, this is easy. Because TZ corresponds with ZS, I know that those two parts are congruent. So I can go ahead and jump here. So I'll say TZ is congruent to ZS. Note that the order of the letters doesn't matter for segments because it could go from either or. It's just in the triangle statement that the order matters. And why do I know that they're congruent? It's because of CPCTC. Because they are corresponding parts, and because the triangles are congruent, those parts are congruent. The corresponding parts of congruent triangles are congruent. That's CPCTC. Okay, so let's look at one more example to help you guys get it. Okay, in this example we are given that LH is perpendicular to RT. I'll go ahead and put that on the picture. That means that these two angles here are right angles. And we know that segment LR is congruent to LT. I'll put that on the picture as well. And while I'm at it, I might as well just go ahead and write that down as my first statement. So LH is perpendicular to RT, and LR is congruent to LT. That's given. Before I can prove that angle R is congruent to angle T, I need to show that those two triangles are congruent. So, which method could I use? Well, I have a right angle. I have a hypotenuse on both triangles. How about I use hypotenuse leg, using that additional shared side in the middle? Alright, so from the given information, those are my hypotenuses. There and there. So I already have my H statement completed in for HL. So I need a leg. What is my congruent leg? It's the shared side in the middle. So I'll say that LH is congruent to LH, and the reason is the reflexive property. Okay? There I have my leg. I'll cross that off. Now, am I ready to say that the two triangles are congruent? Technically not yet. This is something one of the reasons I brought in this proof. In order to use HL, remember you also have to know that it's a right angle. So we need to include that in the reasons before as well. So I'll write that in. I know that angle LHR and angle LHT are right angles. Okay, that will give me the right angle that I need. So, what's my reason for that? Well, at the very beginning we were told that those were perpendicular. LH is perpendicular to RT. The reason those are right angles is because that's what perpendicular means. So the reason for this statement will be the definition of perpendicular. Alright, so since I've established everything I need for HL, let's write our triangle congruence theorem. I can put the letters in, use the first triangle I can put in any order I want. I'll say triangle LHR. The other statement I have to match according to the same order on the other triangle. If I use the same order, I would say triangle LHT. That puts the corresponding parts together. Alright, and my reason? It's the hypotenuse leg congruence theorem. Since I've now established that the two triangles are congruent, now I can say that my corresponding parts are congruent. So now I can say that angle R is congruent to angle T. And the reason? Because those are corresponding parts of congruent triangles. So therefore they are congruent. Okay, I've completed the proof. Now, you might have noticed that there would have been a much shorter way to do that proof if you were paying close attention. If you think of it, tell me in class tomorrow. Alright, so hope this helps you guys. Just one of the key things to remember is first you prove the triangles are congruent, then you can use CPCTC. It's one step farther on the proofs we've already been doing. Okay, we'll get some more practice in class, and I'll see you guys later.